Hello, grade 10s. Here is your video for 6.3 or lesson 3 of unit 6. For this lesson today, we are going to be learning all about slope-intercept form of an equation. Okay, so for the rest of this unit, every lesson is essentially going to be focusing on a different form of an equation. And depending on what form of an equation you're given, you can graph it differently. So slope-intercept form is the first form of the equation we're going to learn. And sometimes I might slip up and call it explicit form. Okay, that's what it's called in French. So if you ever see me write explicit form or say explicit form, I'm really talking about slope-intercept form. Okay. It's called slope-intercept form of an equation because the equation gives us the slope of the graph and the y-intercept of where the line will cross the y-axis at. So if we're given the y-intercept where it crosses the y-axis at, and then we're given the slope, we can draw the line very easily. Okay, so slope-intercept form of an equation looks like this. You're going to have y isolated completely on the left-hand side equaling mx plus b. Okay, so again, slope-intercept form will always be y on the left-hand side, and then on the right-hand side, you're going to have two terms. Okay, this first term here represents the slope. So right here, I say that m, so the number you actually have here in place of m, it won't actually be an m, it'll be maybe a 4 or a 2/5, it'll be a number, but whatever that number is will be your slope, okay? And then the number on the end here, it's just a constant term, it'll be like +3 or -5, but that b, whatever that value is the y-intercept. So we will cross the y-axis at that value given there. Okay, so example number 1, a graph of a linear function. So remember, linear function is just a fancy way of saying a straight line. Okay, so the graph of a straight line has a slope of 3/5 and a y-intercept of -4. What would the slope-intercept equation be? So I want you to write out what the equation would be. So I write out the equation like it would be in red there. So it's always y on the left-hand side equaling. And then I explained that the number that shows up right here, so right after the equal sign, you're going to write down the slope. And it tells me the slope is 3/5. And then you're always going to have an x tacked on to the 3/5. And then the number that follows is simply what the y-intercept is. So it says that the y-intercept is -4. So you just write -4. And there you go. That's the slope-intercept form of that linear function. Let's do another one. A graph of a straight line or linear function has a slope of -7/3 and passes through 0,5. What would the slope-intercept equation be for the function? So again, I give you the slope. So we know that the equation will start off with y equals, then right after the equal sign is the slope. So -7/3x. So that's like my rise over run. Okay, so I know I'm going to rise -7 and then run 3. Okay, here it tells me that I know that the equation passes through 0,5. So I'm just going to sketch quickly the point 0,5. So remember, that's my x value, that's my y value. So if I'm on 0 for x, I'm right at the origin, and then I go up 5. Okay, so that's the point 0,5. And that's the y-intercept, right? We cross the y-axis, therefore, at 5. So all I have to do is say, I cross my y-axis at the +5. Okay, there's just a different way of stating where the y-intercept would be. Okay, so for the next questions here, we have to actually graph. So I'm going to give you the equation in the slope-intercept form, and we have to graph it using the information given. So the first thing I'm going to do is I'm just going to quickly draw a couple of my axes here. So my vertical axis and my horizontal axis. And of course, if you have this handout, you can be doing the same thing. All right. Draw your arrows always on the end of each axis and label them XY. That's just proper math etiquette. Okay, so for this first one here on the left, let's write what we know. So we know that the number that shows up right after the equal sign is my slope. So my slope is 1/2, right? And then I know that the number tacked on the end is my y-intercept. So remember, if we're talking about where it crosses the y-axis at, x is always 0, and then my y is at 3. Okay, so that's just me writing it as an actual point or coordinate. So now all we do is we start here. That's our starting point. So I'm going to start at the point 0, 3, or my y-intercept of 3. Now, my slope is 1/2. So we know from previous lessons in Unit 5 that slope is rise over run. So I'm going to, from that starting point, rise 1 and run 2. Now they're both positive, right? So I'm going to actually go up 1 because it's positive, and because my 2 is positive, that means to the right. So I go 1 up and 2 to the right. And there's my second point. 1 up and 2 to the right. So I always want you to have at least 3 points. So there you go. We did a rise of 1 and a run of 2 a couple of times to get me 3 points. And then to finish off, you join them with a line and arrows on each end. Those arrows indicate that we could keep going if we wanted to. So I'll just show you what that means. If I stopped here, I could again go 1 up over 2, 1 up over 2. It's just a pattern. It's a pattern that never ends. And actually, you can go backwards as well. So if you want to go backwards, we'll return to that starting point, the red point. And if we're going backwards now, we just do the opposite. So if we went up 1 to the right 2, to go the backwards way, we would go down 1 to the left 2. Down 1 to the left 2. Down 1 to left 2, and you'll see it just continues the pattern, but in the other direction. Okay, so you can choose any 3 points you want to draw, but just put arrows on the end of your line there once you connect the dots to show that you know that this is a pattern that could go on forever. Okay, all right, next one. All right, so for this guy, again, let's write what we know. So we know that my slope is -3/4, and then my y-intercept crosses at 2. So that means my y-intercept is 0, 2. So that's going to be my starting point, is that 2 on the y-axis. Now, be careful here with your rise and run. So this is your rise over your run, but because your rise is -3, you're going to go down 3, but your run is positive, so you can go to the right. Okay, so from your red starting point, I'm going to go down 1, 2, 3, and then to the right, 1, 2, 3, 4. Again, down 3, 1, 2, 3, 4, to the right. Now, as always, you can always go in the other direction. And I'm going to explain something here. I'm going to take this slope and I'm actually going to move the negative down. Okay? These slopes are actually the same thing still. In both scenarios, I have 3/4 and the fraction is negative. And I've said this before, it does not matter in a fraction where the negative falls. If the negative falls with a 3, awesome. If the negative falls with a 4, awesome. It still just means that the fraction has a negative value to it. So these are the same thing. You can move around that negative and you're not actually changing the slope. So in this case here, my rise is +3 and my run is -4. So I'm going to the left 4. So you can always do that if you want as well. So starting at our red point again, you could have also gone a rise of 3, 1, 2, 3, but a run to the left of 4. Again, a rise of 3, a run to the left of 4. And all that means is you're doing the same slope, but you're just going in the other direction. And as you can see here, all 5 of these points, that was awful, all 5 of these points join nicely in a straight line. So we know that we actually just drew the same line, but going in one direction for one way and going the other direction for another way. It's the same thing. So my moral of the story is this negative right here, you can decide who it belongs to. Make sense? I hope so. Okay, also, just remember you only need to do 3 points maximum. Okay, if you want to do more, that's great. But, or sorry, 3 points minimum. I need to see 3 for sure, and always put your arrows on the end to show me you know it goes forever. Okay, for these questions here, it's the opposite. I'm going to give you the graph, and now you have to tell me what would the equation be. So to tell me what the equation would be, you need the slope and you need the y-intercept. So to figure out the slope, I'm going to choose the point right here and the point right here. I actually used this graph in an example in Unit 5, I believe, and in that video I explained that you always want to choose perfect points. So I'm choosing these points here because I can see it crosses directly at -3 and here it crosses directly at +6. So when I start jumping, starting at this point, I'm going to jump 1, 2, 3, 4, 5, 6. And then when I start traveling over, I know because I'm at -3, I have to jump 1, 2, 3 exactly to line on that point. So I went up 6 and I went to the right 3. That's my rise over run. So my slope is my rise over my run. They're both positive, and you always reduce to 2. Now your y-intercept, where it crosses the x-axis at, crosses at the y value of 6. So there's the info you need, and now you are ready to write the equation. So it's always y equaling whatever the slope is. Your slope you found to be 2. You always slap an x beside the 2, and then because we cross at the y-axis at 6, there you go. That's how easy it is, you guys, to write the slope intercept form of an equation. Let's do another one. All right, so let's find my perfect points. And if you zoom in here, it might be a little bit easier. So again, I see a perfect point crossing right at x equals 2, and I see another perfect point crossing right at x is 4. So that's going to be my rise over run. So if I start at this point here, I'm going to be traveling down 1, down 2, down 3, down 4. I went down 4, so my rise is actually negative, but then I went to the right 2, and that's positive. All right, so if I write down what I know that my slope is -4 over 2, which is just -2. And remember, that makes sense. The slope should be negative here. We can see that this line is going down. Like if you started up here, if you were running and you started running, you'd be running down that hill. Running down means negative. So we should have a -2 for a slope. That makes sense. Okay, now your y-intercept, where it crosses the y-axis at, crosses at the point 0, 4. So now we have the info we need. Y equals, the slope comes right after the equal sign with an x slapped onto it, and we cross the y-axis at the value of +4. That's right there. All righty. In these two here, I actually gave you the dots, so you know what I want you to travel between. 1, 2, 3, 4. I went down 4, right? So it's -4, and then I went to the right 1. So to the right is positive. Now remember, you can always go the opposite direction. If you wanted to start here, great. You would travel 1 up, 2, 3, 4. So because you're traveling up, that's +4. But then because you had to go to the left 1, that would be negative. In either scenario, your slope or your rise over run is 4 over 1. In the scenario with the black numbers, my 4 would be negative. In the scenario with my blue numbers, the 1 would be negative, but regardless, both of those simplify to -4. Okay, now my y-intercept is where it crosses the y-axis at, which is at +2. So there's the point. Now if I want the equation, I know it's y equals the slope, which is -4, tack an x on, and I cross at +2. And then of course, if you crossed at -2, you would just switch that to a negative. Easy. Okay, this one I saved the best for last. This one's a little bit funny. All right, so we're going to pick 2 points to jump between. If you look along this line, you have a plethora of points to choose from. Those are all perfect points, okay? Doesn't matter where you start, where you finish. Let's start here. I'm going to start here and I'm going to end there. Sure, why not? If I jump, I go 1, 2, 3, 4, 5. That's up 5, so it's +5. And then 1, 2, 3, 4, 5 again. +5. I went up and to the right, so both of my values are positive. So my slope is 5/5. Always reduce that. Your slope is just 1. Okay. Now your y-intercept, where does the graph cross the y-axis at? Here's your y-axis right there. Here's your graph. Where do they meet? Right there at the origin, which is 0. Okay. So your y-axis, or sorry, your y-intercept is actually at 0, 0. Okay, it crosses right at the origin. So now let's write this out. So we know the equation is always y equals the slope. The slope is 1 with an x tacked onto it. And then at the end is where it crosses the y-axis at 0. Now, let's clean that up. That's not proper math etiquette right there. We know that a 1 in front, you wouldn't need to write a 1 in front of that x. It could just be y equals just x. And then why would you need to write a +0 at the end? Okay, if it's a +0 at the end, we don't have to write it. So really what it comes down to is the equation is y equals x, because the slope is 1, there's a ghost 1 right there, and then the y-intercept is 0, and you don't have to write in zeros. And so there you go, y equals x is the equation for that guy. A little bit of a tricky one. Okay, almost done. Last question. For the graph that follows, so this graph here on the right, first of all, determine the slope. Well, we're good at that. Let's do that right away. Let's determine the slope right away. I give you 2 points. 1, 2, 3. So I went down 3, so I have -3. 1, 2, 3, 4, 5, 6. I went to the right 6, so that's +6. All right, so now I'm going to go back here. If I'm determining the slope, it's a rise over run. So my rise was -3, my run was 6, and that reduces to -1/2. It makes sense that my slope is negative because it's a downward slope. All right, then it says write an equation and then verify that equation. Okay, so if I write my equation, we've been doing this a lot so far. My equation is always y equaling the slope. So -1/2 with an x glued to it, and then where it crosses the y-axis at, which here happens to be at +4, right there. But then it says verify. So we did a bit of verifying in Unit 5. We've done a lot of verifying in this course. That means that you choose any x value you want. So this is my verifying step. I'm going to choose any x value I want. I'm going to choose, let's say x equals 4. Okay, I am choosing an x value that I can see here and that hasn't already been used yet. So I've already used the x value of 2 and I can already see an x value of -4. So I'm not going to choose those ones. I'm going to choose something different. So x equals 4. And what I do is I just plug that into my equation. So -1/2, but instead of x, I have 4 now, plus 4. And I'm going to simplify this. Y equals, now when you multiply a fraction to a whole number, imagine that that is just over 1. And all you do is multiply the top number, so -4. And then when you multiply the bottom numbers, it's 2. I'm going to continue up here. Oops. Now, when you reduce that, -4 over 2, or -4 divided by 2 is just -2. And then I'm adding 4 to it. And then in the end, -2 plus 4 equals 2. So that's what the equation simplifies to. So what that means is I'm saying that if my equation is right, I should have a point at where x is 4 and y is 2. So x is 4, y is 2 right there. Perfect. That's on the graph. So I know the equation we created is right. Okay. Then it says, use the equation to calculate the value of y when x is 10. Okay. So this is just another way of us using our equation to find another point on the line. So they want us now to solve for y. What would y be when x is 10? All right, so this means negative 10, negative 1 times 10. I'm just multiplying those together over just a 2. You do not also multiply the 2 with a 10. That is a very, very common and frustrating error. There is a 1 underneath of that 10. 2 times 1 is just 2. And then we add 4. Now let's simplify. Y now equals negative 10 over 2, which is negative 5, plus 4. And that equals negative 1. So that means that when x is 10, y should be negative 1. Let's go check that. So here is x 10. Then I have to go down to negative 1. And there you go. There's that point, which is also on the line. So we know we did our work right. Okay. All right. So there's a whole bunch of examples and information on slope-intercept form. Here is an assignment to follow. Good luck. As always, send me questions if you have them.